Well, welcome back to another review session. Tonight's focus is on completing the square for quadratics and circles. So most of the time we would use quadratic formula, but here's when I would use completing the square. If you can't factor quadratic function, A, like I said, use quadratic formula, probably the safer method, and then 2 would be completing the square. So let's run through our steps on how to complete the square. Remember, it has to be quadratic, ax squared plus bx plus c equals 0. So here's what we do. We cut the b term in half, square it, add it, then subtract it, group the first three terms together, factor. And remember, the a value in front has to be the number 1. So what if it's not? Then you simply divide by the a value. So let's solve this by completing the square. Now again, I want to remind you, I would normally use quadratic formula. This is kind of like a last resort, or they're forcing me to do it. Quadratic formula is much simpler. So I'm going to take my b term, which is negative 10, cut it in half, our directions just said. I get negative 5, wrap that baby up, square it, and I will get 25. You will always get a positive number when you square something. So I have x squared minus 10x. Here's where you insert it. We're going to add 25 and subtract 25, and we'll keep our plus 13 on the end. Now, yes, they have to go in that order. Okay, your adding and subtracting has to come right after the x. Our next term said take the first three terms and factor them. So that's x minus 5 times x minus 5, and then I'm going to rewrite that really as x minus 5 squared. And then I'll add these together. I have negative 25 plus 13 gets me a negative 12 equals 0. Okay, so right now I want to be very clear. I want you to box that in, and I want you to make a note that this is called vertex form. This is the vertex form of a parabola because we can see exactly where the vertex is. Let's make a quick sketch. This is saying shift your parabola right 5 and down 12. So if I go right 5 and down 12, it's down here. It's a positive x squared, so I know this parabola opens up like this. Now, if it says solve this equation, we're going to take it another step further. So let's rewrite it. X minus 5 squared minus 12 equals 0. And let's actually solve for x. So to solve for x, you isolate the x. So I have x minus 5 squared equals 12. And then you say, okay, how do you get rid of a square? You square root both sides. Now here's what you can't forget is that when you square root, you get plus and minus. So this becomes plus and minus radical 12. Now, maybe you should make another note for yourself. You want to simplify the radical before you do anything else. Okay, now notice my plus and minus is going to stay in front. Simplify this radical. I'm thinking 4 times 3, which is really 2 radical 3. Notice my plus minus is in front of the simplified radical. It has to stay in front of this radical term that I simplified. And then I can lastly add over that 5. So I'm going to say it's 5 plus or minus 2 radical 3. Okay, and recall that means there are two solutions, 5 plus 2 radical 3 and 5 minus 2 radical 3. Okay, we'll try a little uglier one. 3x squared minus 12x plus 27. Again, I would typically use quadratic formula. Okay, this is only in the case they tell me that I have to complete the square that I'm going to do it. So this a term has to be a 1. So I'm going to divide everybody I see, every term, there's 4 terms, including the 0, by 3. So I get x squared minus 4x plus 9 equals 0. 0 divided by anybody is 0. Okay, and now we'll just run through those steps again on completing the square. Take that b term, cut it in half. So that's negative 2, wrap that baby up, square it, I get a 4. And again, that will always be positive because you're squaring it. So x squared minus 4x, add your 4 and subtract your 4. Then I have my plus 9 equals 0. Group those first three terms together. They should factor to be the same, x minus 2 times x minus 2, which is really x minus 2 squared. So I took care of those 4. Add these together, I get a positive 5 equals 0. Okay, so again, vertex form. If they say what's the vertex of this parabola, I know I went right 2 and up 5. So I'm going to go right 2 and up 5, and it's a positive x squared, so it opens upward. Then I can easily solve this for x. So x minus 2 squared plus 5 equals 0. Step 1, get that x by itself. So x minus 2 squared equals negative 5. Take the square root, and don't forget that plus minus. So x minus 2 equals plus or minus radical negative 5. Make that note. You want to simplify that radical. Now I can't really break down 5, but I can break down that negative. A negative under a radical comes out as an I. But remember, the plus minus is what gets written down first, so I'll have I radical 5. And then I'll just add over that 2, so I get 2 plus or minus I radical 5. So these roots are imaginary, which if I look at my picture, it makes complete sense. There are no roots here. They're imaginary. They do not touch the x-axis. Okay, now the next one I made extremely ugly because everybody's not divisible by 4, and that happens a lot. You just got to go with it. So again, I can't complete the square till that first term's a 1, so I'm going to divide everybody by 4. So that's x squared minus 5x equals negative 9/4. Yuck. But we got to go with it. All right, so I'm going to take my b term with the x, cut it in half. Again, yuck, it's not pretty looking. Who cares? Wrap it up, square it. When you square a fraction, you square the top and the bottom. So I'm going to get 25 over 4. That is the number I'm going to add and subtract. So plus 25/4 minus 25/4 equals negative 9/4. Okay, that means you got to factor these first 3 terms. And again, yuck, you've got to factor with a fraction. So x and x. What makes 25 and 4 a perfect square? Well, 5/2. And one little trick is it's always the number that you squared. So I squared 5/2. That means this is going to be 5/2. If I have to multiply to a positive, then these are either both negative or both positive. I'm adding to a negative, so they're both negative. So I know this is really x minus 5/2 squared. And this is why quadratic formula would have been a million times easier. But they said complete the square, so that's what we're going to do. I'm going to take this negative 25/4 and I'm going to add it to the other side. So I have negative 9/4 plus 25/4. So I'm going to get positive 16/4. Okay, so again, I'm going to go ahead and solve this. I'm going to square root both sides. So x minus 5/2 equals plus or minus radical 16/4. Simplify your radical first. X minus 5/2 equals plus or minus. I know the square root of 16 is 4, and I know the square root of 4 is 2, so that just becomes 4/2, which is actually really nice, which just becomes 2. And then I will add this over, so I'm going to get 5/2 plus or minus 2. Now just to be clear, there are 2 answers. There's 5/2 plus 2, and then there are 5/2 minus 2. And obviously you can type that in your calculator to get the exact answer. When else would you have to use completing the square? Well, you have to do it when you have the equation of a circle. Now how do I know this is a circle? Well, look, I've got not only an x squared, but also a y squared. Okay, so this is not a function, it's a circle, it does not pass the vertical line test. So the first thing I want to do is order these functions. Now we typically put the x's first and the y second. So I'm going to start rewriting with x squared plus 2x. So I'm putting my x terms first and then plus y squared. I'm going to move that 24y over, so minus 24y. And you can leave the negative 120 there. That really doesn't matter. Okay? So again, I'm just going to line them up, x's first, y second, in order. And then I'm going to go through and complete the square twice. So there's my b term. Take that b term, cut it in half. That's 1, square it, and I get 1. Take this b term, cut it in half. That's negative 12. Square it, and I'm going to get 144. So let's run through a circle completion, the square. X squared plus 2x. I'm going to add 1 and subtract 1. Plus y squared minus 24y. I'm going to add 144 and subtract 144. And this is still going to equal negative 120. All right, now we, just like we normally do, take the first 3 terms, factor them. So that's really x plus 1 times x plus 1. So I'm going to call that x plus 1 squared. Now don't forget, you still have this minus 1 hanging out. I'm going to do the same with these first 3 terms. This is really y minus 12, y minus 12. So that's plus quantity y minus 12 squared. And again, you still have that negative 144 hanging out. and that's all equal to negative 120. Okay, now, these single terms are going to go together, so that makes negative 145, and I'm going to bring those over to the other side, so I'm going to add over 145. So now I've got x plus 1 squared plus y minus 12 squared equals 25. So now I am in the standard form for the equation of a circle. So what do you have to be able to pull out? Well, let me rewrite standard form for you. It's really x plus h squared plus y minus k squared equals r squared. So the question is, if r squared, if you know it's everybody is a squared term, this term squared, and this is something squared, here's all I do. I just say r squared has to equal 25, whoops, and then I figure out who r is. So if I know this last term is r squared equals 25, square root, I know my radius has to be 5. Now why am I not saying plus or minus 5? Well, a radius has to be positive, of course, because it's a distance between 2 points, and your distance is always going to be positive. So the center of this circle, remember we're going to take the opposites when we go horizontal. So I would say my center is negative 1, positive 12, and it has a radius of 5. Okay, now even uglier is if that coefficient isn't a 1, because remember, to complete the square, our coefficient has to be a 1. So in this case, I'm going to divide every term I see, all of them, by the number 3. Again, even the 0. Everybody gets divided by 3. You can't leave any term out. So I've got x squared plus y squared plus 14x minus 12y plus 4 equals 0. Okay, so now I'm going to group them together. So x squared x plus y squared minus 12y plus 4 equals 0. Okay, we're going to complete that square twice. My b term is 14. 14 over 2 is 7. Wrap it up, squared, 49. I got negative 12 divided by 2. Wrap it up and square it. That's negative 6 squared. I'm going to get 36. So I'm going to say that's x squared plus 14x plus 49 minus 49 plus y squared minus 12y plus 36 minus 36. And don't forget you still have that plus 4 equals 0. Okay, we'll take those first three terms. So that's really x plus 7 and x plus 7. So that's x plus 7 squared minus 49. Take the next three terms. That's y minus 6 and y minus 6. So that's going to be plus y minus 6 squared minus 36. Still have a plus 4 equals 0. All right, so I'm just going to add my terms together. I can have negative 49 and negative 36. And then a positive 4 I want to add together. And I think that leaves me with negative 81. So I have x plus 7 squared plus y minus 6 squared minus 81 equals 0. Bring that over. X plus 7 squared plus y minus 6 squared equals 81. Okay, so again, I want to think of it as this thing squared plus this thing squared equals something squared. What is my something squared? Hopefully you're saying that's really 9 squared. So my center is going to be negative 7, positive 6. Again, horizontal shifts go in the opposite direction. And my radius is just going to be 9. Now, here's what the Regents did to us a little while ago. They took this whole thing, and it wasn't a choice on the multiple choice, but all they did was they multiplied every coefficient by something. So they went through, let's say they multiply by 2. Then it's really 2 times x plus 7 squared plus 2 times y minus 6 squared equals 162. And this blew people's minds. But all they did is they went through and they just multiplied the coefficient here by 2, the coefficient here by 2, and this by 2. You could do it with any number. You could do it with a half, 10, 15, 20, 1, 7, 8, 9. Just go through and multiply by a certain number if it's not a choice. Well, that does it for our quick review on completing the square for quadratics and circles, and we'll have some great practice tomorrow.